Today we're talking about Ka. We're doing this so we can predict the pH of weak acids, and our success criteria is being able to use Ka to calculate hydronium ion concentration or pH, and vice versa, starting with the pH or hydronium ion concentration, being able to figure out Ka. So the 6 strong acids, they react quantitatively with water, which means they react more than 99.9%. It's a 100% reaction for all intents and purposes, which means the concentration of the original strong acid and the hydronium ions is the same. The weak acids don't. The weak acids react in equilibrium. So like every other equilibrium, if we want to find out what the final hydronium ion concentration is, we need an equilibrium constant. And this is one of the biggest applications of Kc. We specifically, though, name this equilibrium constant Ka. And the reason we do that is that all acid-base equilibriums follow the same reaction pattern. So for all acids, we can calculate Ka. Its equilibrium law will always be equal to the concentration of the hydronium ions times the concentration of the conjugate base over the concentration of the original acid. These Ka's are only accurate to 2 significant digits. You'll notice that if you check in your data book, all of them are 2 digits. And often these will pass the rule of 1,000s. If you do look at the data book, you'll see that most of these Ka's are quite small. So if you start with any reasonable concentration that's around a mole per liter or half a mole or even 1/10 of a mole per liter, it's very easy for these to pass the rule of 1,000s, which means the change in the original acid's concentration is negligible, and it makes our calculation so much easier. So this is where ice tables are going to come back in. If you don't pass the rule of 1,000s, these can be tricky because it means you have to use the quadratic equation, because you're going to end up with a quadratic formula when you do all of the math. But the nice thing is that if it does pass the rule of 1,000s, the math is really, really simple, because it means that you'll have both Ka as a solid number. The denominator of the equilibrium constant will also be a number without a variable, and then you'll probably have x squared on top. So all you have to do is solve for x. So this greatly simplifies the algebra that we need to worry about. Makes our lives much, much easier.